Flying cars are kind of the perennial dream of the future. You know, we have everything else that was dreamed up in science fiction over the last 100 years. But when we look in the sky, like, where are the flying cars?
Electrification is beginning to transform the way we get around cities on the ground. But all over the world, the race is on to take to the sky. Over the past decade, flying cars have grown from a dream for billionaires to a realistic goal. Over 300 companies are now developing electrical vertical takeoff and landing aircraft, also known as eVTOLs. In a few years' time, the skies above us could look very different. But first, flying car startups must overcome mammoth challenges. Sebastian Mores is CTO of Volocopter. Good morning, Sebastian.
Hi, Emma.
Good to meet you.
Nice to meet you.
Wow, look at this. This is it. This is the Volocopter. So launching next year, you're going to be the first, is that right?
Launch date is next year when we go for the type certificate for the aircraft. We break the ice for the very first time. That's why we start with a two-seater. Quite simple, straightforward.
So I think one of the first things we all need to understand is it's not a helicopter. For a start, it's electric.
It's electric, it's not a helicopter. The electrification is just a result for the decarbonization of the entire industry. So point number one. Point number two, it's not a helicopter. To be in that market, to fly in the city, a helicopter is not the right vehicle actually. It's not safe enough. We have certain restrictions, so it's 100 times as safer than a helicopter and similar to the airliners actually.
Volocopter is working on 3 types of electric aircraft. The VoloCity, a flying taxi, which they plan to launch in 2024. The VoloRegion for longer trips, and the VoloDrone for cargo, which they're developing at this site in Munich.
Here is a prototyping space and a space for producing, developing new types of technologies and do the first step when it comes to exploring new tech, be it batteries, propellers, aircrafts, ergonomic mock-ups, flight control system, electronics, and so on.
Can we get a little closer? What's this one called? Because this is not the one that we're going to see next year.
No, this is a prototype called the VoloRegion, the next generation of aircraft, longer range, more passengers, higher speeds, and it's in fact an airplane. So it's designed in order to have airplane characteristics. We do not see now the motors and everything installed here, so the electronic components, but it's a vertical takeoff airplane in the end.
So what's this one over here?
That's our VoloDrone, heavy lift unmanned cargo drone.
Okay.
It's the same architecture as the VoloCity, a bit smaller, a bit lighter, but this should fly then autonomously from A to B wherever the customer needs this.
So these are not blades, or what do you call this?
We have the rotor plane. On that rotor plane we have 18 rotors and 18 propellers. And those secure our safety, they reduce our acoustic footprint to a very low level in order to be not annoying, because we're going to have hundreds and thousands up in the air and nobody wants to be annoyed.
And what about the safety?
So by definition of the EASA regulations, we have to provide the safety level 10 to the power of -9, which means 1 incident in 1 billion flights.
1 billion?
1 billion flights, especially for the manned aircraft. So we have to prove this. We have to have the certain evidences. We have to have the certain rectifications for this.
Why is this safe?
We can lose up to 3 rotors or motors or even certain batteries and a combination out of this. And that makes it safe. So we have a redundancy and we have a certain dissimilarity also on board on the aircraft.
What does that mean?
Dissimilarity means that we have, for example, for one function, be it a signal goes from A to B, we have that in 2 different software states. We have that communication line in 2 different lines, be it glass optical fiber and plastic optical fiber. So that means dissimilarity. Redundancy means that for one function we have multitudes of certain elements, which means we have 8 batteries on board or 18 rotors, whereas 2 or 3 can be shut off during flight, for example.
Safety is paramount, which is why Volocopter has their work cut out in the run-up to the launch. Around the world, there are different aviation authorities that must certify an aircraft as safe. It is currently working towards achieving certification from the European Aviation Safety Agency, or EASA. I'm guessing this is a very old prototype, considering the nose on this thing.
Yes.
As well as safety, a lot of thought goes into how the aircraft look and the passenger experience. So is this the configuration of the seating, or is this quite an old concept?
This is an old concept. So what we had to figure out is how we place the passengers, what is the entry height, how do we step in, how much headroom do we want to have, how do we close the doors, do we want to have classical doors, swiveling doors, how does that look like? So what's the architecture of the interior? How is the field of view? How does the pilot step in? How does it control the aircraft? So this is all then also combined with virtual reality.
So a lot to consider. The final design for the VoloCity is complete, and they have partnered with key public transport authorities in Paris to bring the plans to life, including running a trial phase with test flights, route mapping and coordination with other French authorities. The VoloCity will be the first aircraft to launch next year in Paris. So multiple launch pads around the city?
Yes, we're going to start with Paris. We have 5 launching routes. We're going to break the ice with the two-seater VoloCity. So the VoloCity has the same architecture which we have invented since the beginning of the company, since 11 years. We had several iterations. We have 18 rotors, the same we have also in the VoloDrone.
The VoloCity can carry a pilot and 1 passenger and will take off from special launch pads Volocopter is calling Voloports. So will there be a launch pad actually in the city, not just around the city?
It will be in the city because in the end that's where we target. It doesn't make sense to have it only in the outskirts. We want to reduce the burden for the passenger going from the outskirts, from the airport into the city, but we also have inner city ports in order to travel in the city. Probably not in smaller cities, but in very big cities definitely.
It looks cool, it's exciting because it's new technology, but do you really know how the public's going to react? You know, they're in the city and these machines, these aircraft are flying backwards and forwards.
Yes. So we did an analysis when we were flying the aircraft in 2021, over 10,000 people. Before that flight, the perception was rather negative because they just didn't know it. And afterwards they were saying, yes, we can imagine that this is going to be flying in future. They did not hear it. It was safe from their perspective, and they didn't even know that was flying above their heads, actually. At the Paris Air Show, we were also flying on the flying display, and the radio commentator was far noisier than our aircraft. We did not even hear that. Nobody knew that we were flying, actually, which is good on one side, and the other side was like a pity because nobody's...
Oi, look at our machine!
Yes, but there were plenty of people viewing us.
The real test of public perception will be in Paris, but why wouldn't you love a flying taxi? Plans are also in place to launch in other cities, including Rome, Helsinki, Stuttgart, Dubai and Singapore. They also recently performed the first eVTOL test flight in the Kingdom of Saudi Arabia at the NEOM Urban City project. Their plan is to complement the short city flights with an aircraft that goes the extra mile. The VoloCity and the VoloDrone are very, very similar. Tell me a bit about the Volo region because it's got wings instead of the rotors.
The 60% roughly of the market is being covered by multi-rotors. When we go for the next share of the market, we have to have wings. We have to create a certain efficiency levels for the aircraft from aerodynamic perspective.
So it's still vertical takeoff
Yes.
and landing?
It's a so-called hybrid configuration, or also known as lift and push concept. We have a dedicated system to lift the aircraft and push the aircraft forward. And between those phases, we have the so-called transition phase, and that transition phase is typically quite complex. We mastered this from our side, so that we have roughly 30 seconds of lifting phase going to the transition and then have pure airplane. We shut off those lifting rotors and then we can fly like an airplane.
And how fast will these aircraft go?
The Volo region will roughly target a cruise speed of 150 kilometers per hour. The aircraft can be faster, but we have figured out that for the market case, for that range, it doesn't make sense to have 300 kilometers or something beyond, like some competitors do. It's quite decent, but it fits fully the market.
We're a year out. What needs to happen in the next few months?
It's a very tough time currently. We're producing one aircraft after the next. We're at the serial number 3 currently. 4, 5 is being now currently developed until end of this year. And those aircraft have to provide the evidence towards the authority, but also to us internally, that we're safe and that the architecture and the design is correct, quality is correct, and that we have, as a company, the competence to enter the market.
Sleepless nights?
No.
Super
We're good.
confident.
We're good.
A lot of confidence from Sebastian, which is what's needed when you're facing a lot of competition. However, not all are taking the same approach, and there are many different designs for eVTOLs. In China, EHang have just delivered 5 flying cars for use in Shenzhen for aerial tourism and are set to deliver 95 more after recently receiving approval from the Civil Aviation Administration of China. Another Chinese company, Xpeng Aero, gave a glimpse of the future when its X2 eVTOL made its first public flight in Dubai. The X2 flew for 90 seconds unoccupied, but can carry 2 passengers and luggage. It has 8 propellers powered by 8 electric motors and has a maximum speed of 130 km per hour with a flight time of 35 minutes. Xpeng believes it will be ready to launch to the market by 2025, but still needs regulatory approval.
We are now in the researching process, step by step to the international market. Dubai is the most innovation cities in the world, and this is our first public flight globally.
In America, Joby Aviation has begun piloted test flights of its aircraft with 6 electric motors that can carry 3 passengers and travel at a top speed of 321 km per hour. But one Australian company has an approach that could speed up the process of bringing flying cars to the private market. Matt Pearson is co-founder of Airspeeder.
It doesn't matter whether we had a vision of a dystopian future or a very rosy view of the future we'd be in by now. Those pictures always have flying cars in them. So I kind of thought, well, why don't we have this? When we have a lot of the technology to make it possible, what's still holding us back from this dream that we all seem to share on some level? We fell in love with the motor car as a culture. We need to see that kind of same love for these next vehicles. And for instance, it's not necessarily easy to fall in love with an autonomous car. You know, there's some sort of magic and I guess the sense of freedom that we have getting into our cars that is missing from a lot of this purely autonomous future. Let's create a vision of the future that is something inspiring and something magical, and sports competition is something I think we all get excited by. And I always say, who is not going to watch a flying car race?
He's got a point. This does look very exciting. At the moment, the flying cars are being raced unmanned.
The stage is set for the world's first ever eVTOL circuit race. And they're off. Team Silver is taking on Team Black.
The first ever race took place in March 2022 and involved 2 pilots competing on a 1-kilometre augmented reality racecourse above the salt flats of Lake Lochiel near Adelaide, South Australia.
Unbelievably close. What a move from Fabio.
This is incredible. What an attack.
They used remote piloting stations that gave them views from the cockpit, similar to what onboard pilots would see. The race was run in 2 sessions with pit stops for swapping batteries.
An Airspeeder is just over 4 meters long. It's very light though, only a couple of 100 kilos of weight. It's all carbon fiber and aluminium, so extremely, extremely light.
Team Silver crossed the line first.
For now, we just go as fast as we can. So it's got about 10 minutes of flight time in the current models. And we kind of get around that problem by having electric pit stops. We land, we change the battery packs out. The top speed, we're aiming for about 200 k's an hour. I think we can probably push it faster in future, but 200 k's an hour just off the ground feels pretty fast to me for now.
Airspeeder has developed its own propeller layout for greater manoeuvrability.
The layout of propellers, I mean, every eVTOL, electric vertical takeoff and landing company does something slightly different. Some companies are focusing on having a bit of a wing and smaller motors and lots of them, like Lilium. People like Volocopter are 18 rotors, so they've got a lot of redundancy. The benefit of these electric flying cars is that they do have redundancy in their design. They have very few moving parts. And if you lose a motor, if something stops working, you can still fly safely, which is great. So we've paired our rotors into 4 pairs. So it's an octocopter, but it's in a quad configuration. And that's for maneuverability. If you look at other racing multicopters, little ones, you know, they're always in a quad configuration because it gives you a lot of speed and a lot of maneuverability. Because we're not building an air taxi, we're not looking at having ultra redundancy. We're more interested in performance.
The quad design also looks the part. Felix Perron is head of design.
The inspiration comes from the Schneider trophy, which was a famous seaplane trophy back in the 30s, I think. The car industry as well, we wanted the vehicle to look like a Formula One from the 60s. And the drone industry as well. I mean, obviously the vehicle at the end of the day is still an octocopter with multiple spinning propellers. So it has to look like an aircraft from the old days, a classic Formula One, and a multicopter.
The designers work closely with engineers to make sure these aircraft can go as fast as possible. Annie Mossman, a mechanical engineer, is concentrating on the powertrain internal system that propels it forward.
When you're in the sky, you need that thing to be as light as possible, and that is one of the biggest design issues that we're looking at. Even more to that, you're looking at balancing. The more power you put into that vehicle, the heavier it gets. On a flying vehicle where you've got electrical powertrain, it's a little more complex. You've got your battery, your ESC, which controls the power given from the battery and the speed of each motor. That's giving the signal you require going to the motor. And then you've got other little systems like your flight controller is kind of an accessory to the powertrain, but your motors and your propellers, that full system is all pure powertrain. All of that is required for you to take things from where you're getting the energy from the battery and you're putting that through the propellers to turn that into thrust. We're moving towards the spot where we've got the safety features to put somebody in a vehicle like this. Then you also have to look at, all right, well, what material do we have to build the casing for the battery out of to make sure it's lightweight, not going to break structurally when you're flying, and it's going to protect the pilot from those batteries. What fireproofing do you maybe have to put in there? Just really like all those safety features.
The other key aspect of the design is navigation and collision avoidance systems.
Luckily, because they're really big multicopters, we can put a lot of sensors into the vehicle. And we generally talk about a combination of radar, LiDAR, and machine vision. So you've got lots of overlap in the types of sensing that you're doing. And the idea there is to create sort of autonomous race controls, basically. So the vehicles will be able to sense where each vehicle is and get as close as possible without touching. So creating a sort of virtual force field between the vehicles.
Just like F1 and Formula E have helped push forward car technology, the Airspeeder flying car racing series hopes to do the same with flying cars. Jack Withenshaw is co-founder and based in London.
120 years ago, names like Charles Rolls of Rolls-Royce, Enzo Ferrari, Henry Ford, these were all racers. They started their careers in racing, and from racing, they developed a commercial consumer model. So we believe that history is going to repeat itself. It may start with taxis, but our gut feeling is racing is an environment in which you can push the technology quicker. Its regulation is authorized at the moment, and we can have a lot of fun doing it. So start with racing and then move into a private and luxury market in the future.
Where are you in the journey and what's the next step?
In 2021, we launched the Mark III, which was an uncrewed prototype. Now the Mark III has done over 700 kilometers of racing. It's done over 300 test flights, and it's done 2 MVP races to date. Now that Mark III is going to continue on in the EXA series, the EXA, which stands for External Aviator. But the interesting element is we're bringing in a crewed series, Airspeeder, and that starts this year. So we're having our first test flights with the manned vehicle this year, and our first manned races in 2024.
These pilots, what kind of background? I mean, I'm presuming they need to be able to fly a plane.
We don't know where the future of the pilots of this industry will come from, and especially for us. So we're sourcing from all different backgrounds. We've got drone racing, aviation, military, even motorsports. So most recently we've taken on Bruno Senna, of Ayrton Senna's nephew, to come and join us into EXA series and be racing in 2023. But for us, it's to understand what all these different backgrounds offer to the series, and so we can understand where the future talent pools for this sport lie. Now for the future of aviation, they probably will have pilot backgrounds, but the reflexes and skill that you get from motorsports, as well as military or commercial aviation, we've got a gut feeling that's where we're going to be sourcing our pilots from.
So a lot to look out for in the coming years, and the sky could be filled with lots and lots of flying cars.
If there's multiple companies with multiple aircraft, it could get a little messy up there, couldn't it?
No, because everything is being then controlled via a certain system. So it's not like that everybody can fly around as they want. We have dedicated landing sites and dedicated rules for each and everybody.
So it pays to be the first.
Yes, that's the major challenge, I think, for every company, which not only has a new tech, but also enters a new ecosystem which was not existent. It doesn't make sense only to have the aircraft, because you have to fly the aircraft, you have to have trained pilots, you have to have the authorities with you. So there's a multitude of elements which come into play here.
So what's the big picture here? I mean, how does this help us, the public?
The big picture in the end is also to have a seamless travel. Going from here to your destination, you will have multiple ways of traveling, and the air taxi service will be one of them.
And reducing congestion too?
Reducing congestion or overflying the congestion, and that will be accessible for not the rich guys, but for everybody in the end.